Welcome back to Matiq News. I'm Eva, and with me, as always, is Akash.
Hey everyone, great to be here again. In this episode, we're diving into something truly foundational, the moment machines started learning not just from rules, but from experience.
Exactly. This is the era when artificial intelligence began to find depth, when layers of logic evolved into layers of understanding.
From simple perception to pattern recognition, this is where the deep revolution began. There was a time when artificial intelligence felt like a promise that never really arrived. We built rule based systems, logic programs, expert systems, but they all hit the same wall. Machines could calculate, but they couldn't perceive.
Right. If you showed those systems a picture of a cat, they didn't see a cat, just numbers.
Exactly. The missing piece wasn't power, and it was understanding. Then someone asked a different question. What if intelligence doesn't come from one big, clever idea, but from layers of simple ideas stacked together?
Like how the human brain processes vision.
Yes, in our visual cortex, neurons detect edges, shapes, objects, meaning, layer by layer. That is the essence of deep learning. And the person who refused to let that idea die, even when the entire field abandoned it, was Geoffrey Hinton. In 2006, he introduced deep belief networks, allowing neural networks to learn one layer at a time without constant human correction.
Okay, but when did this actually prove itself?
2012. One of Hinton's graduate students, Alex along with Ilya Sutskever and Hinton, built a deep neural network called AlexNet. They entered a global image recognition competition called ImageNet. And AlexNet didn't just win, it crushed every other system. It cut the error rate in half.
That's the moment everyone realized this works. So what made the difference? New map? Some secret algorithm?
No, video game graphics cards, GPUs. The same chips designed to render explosions in Call of Duty turned out to be perfect for training neural networks and thousands of small calculations happening in parallel.
So gaming helped spark the AI revolution.
It did. And once training became fast, curiosity became cheap. And that unlocked everything. New architectures emerged. Convolutional neural networks for vision, recurrent neural networks for sequences, LSTMs for long-term memory.
But it's still numbers. How does meaning come from that?
No single neuron knows anything. Each layer makes a tiny adjustment, but stack enough layers and meaning emerges. Intelligence doesn't get coded. It forms.
So deep learning didn't just replicate intelligence, it revealed how intelligence might actually arrive.
And here's the paradox. These networks became so deep that even the scientists who built them couldn't always explain their decision. Deep learning is the first technology that works better than we fully understand.
That's beautiful and also unsettling.
Both are true. We've moved from rules, learning symbols, perception programming, emergence. Now that machines can see and speak, and the next step has already begun. They're learning us.
We've seen how layers of logic became layers of learning.
And how deep learning reshaped not just what machines do, but how they grow.
But intelligence doesn't live in isolation. Once AI learned to see and speak, it was time to connect to something much bigger.
The world itself, the age of data.
That's where we go next in episode 4, when AI met the world. Thank you all.